Welcome to our first submodule on geometry. This submodule will focus on lines, which is an ancient subject in mathematics. In fact, one of the first geometry books ever written was focused on lines. This goes back to the time of Euclid in around 300 BCE. For the CLEP exam, we'll focus on two major ideas in lines: the idea of parallel lines and the idea of perpendicular lines. So we'll start with a mathematical definition. We say that two lines are parallel if they never intersect. That is, the two lines never hit each other. They always sit at a fixed distance away. We say that two lines are perpendicular if they intersect in a special way. If they intersect at a 90-degree, also known as a right angle. So let's look at some pictures of parallel lines and perpendicular lines to make this mathematical definition more intuitive. So we'll start with parallel lines. So perhaps here is the first line, and then the second line will never intersect with it. Now you might notice that it looks like these lines have the same slope, and that's true. That is one way to characterize parallel lines for our purposes, and we'll get to that momentarily. Let's look now at perpendicular lines. So I'll draw some axes. So here's the first line, and the second line is going to intersect with this one at a right angle. So perhaps something like this. Now the key point here is that the angle between them should be 90 degrees. A 90-degree angle is sometimes also called a right angle. So we have a visualization of these lines. We'll also try to characterize them in terms of the slope of these lines. Here, these have what look like the same slope. In the picture for perpendicular lines, perhaps it's not as obvious that there's a relationship between the slopes, but there is. The slopes are opposite reciprocals. So we'll characterize this mathematically as follows. We'll say that two lines, y equals m1x plus b1, and y equals m2x plus b2 are parallel if, well, the slopes should be equal, which means that m1 should be equal to m2. And they are perpendicular if the slopes are opposite reciprocals. So if m1 is equal to negative 1 over m2. So I think that the characterization for parallel lines is fairly straightforward. They should have equal slopes. For perpendicular lines, it's a bit more complicated. They have to have opposite reciprocal slopes. So let's now look at a few examples to try to determine if, by looking at the slopes of the lines, we can determine if they're parallel or perpendicular. So we'll start with the following. The first line will be y equals 3x plus 1, and the second will be y equals 3x minus 6. And we ask, are the slopes equal or opposite reciprocal? In this case, the slopes are equal, so we can conclude that they are parallel. The slopes are equal and equal to 3. The y-intercepts here, the 1 and the negative 6 respectively, are irrelevant to the question of if you're parallel or perpendicular. Let's look at y equals 3x plus 1 and y equals 1/3 x minus 2. And we ask again, are the slopes equal or perhaps opposite reciprocal? In this case, it looks like that they might be opposite reciprocal, but they're not. They're just regular reciprocal. 3 has reciprocal 1/3. If for them to be parallel, this would need to be negative 1/3. So, I'm sorry, to be perpendicular. So in this case, they're not parallel or perpendicular. Let's look at another example. Y equals x plus 1 and y equals negative x plus 2. And we ask about the slopes. Are they equal? Well, no in this case. The first slope is 1 and the second slope is negative 1. So they're not equal. But they are opposite reciprocals, because this is the same as negative 1 over 1, which is negative 1 over m1. So from this observation, we conclude that the lines are perpendicular. Great. The last example I want to show you is one in which the lines are not in the form y equals mx plus b. That is, they're not in slope-intercept form. So we must start by converting to this form. It just means we have a little bit of algebraic manipulation at the start. So we'll look at 3y equals 4 minus x, and 2x equals 6 minus 6y. So we start by converting these to slope-intercept form, dividing the first by 3, the second by negative 6. So I get this. And now I ask the question, are these parallel or perpendicular? Well, the slopes are equal, which implies that they are parallel. So for the CLEP exam, one should know what it means to be parallel and perpendicular intuitively, and also be able to do this sort of more careful analysis of the slopes to determine if you are parallel or perpendicular.